No problem. So let's do some Met Practical. This is a little bit easier because we've probably done half of this stuff before. I'm pretty sure everybody here knows how to read METARs and TAFs. What I'm going to try to do is just point out the obvious stuff and what to expect on the exam. And then there's a few things here and there that everybody forgets. So I'll hopefully remind you on that. Now, on the exam, what you can expect is something very similar to what we do in our textbooks. You're given a whole weather package. Includes a bunch of charts, including a bunch of METARs and TAFs. And you may be asked to refer to individual parts of it, or you could have to look at all of it to answer a question. And it totally depends on the question. So they could say, referring to the METAR, what's happening, or they could say, you're on a flight from point A to point B, what can you expect en route for landing, this kind of thing. So it totally depends, but you're likely going to be given a whole package and then ask questions on it, just like what we've done in the workbook. So first off, who's responsible for providing us with aviation weather in Canada?
4 per day. I don't want 10.
What?
Who gives it to us?
NAV Canada?
NAV Canada, exactly. Now, they provide us with the weather, but they don't create the weather. They just give us access to it. The people that create the weather, it could be Environment Canada, it could be other countries providing it to us. NAV Canada is really just the go-between. So that's important because depending on what kind of weather you're looking at, maybe it's national, maybe it's ICAO, and some of the terminology and stuff can be different based on whether it's Canadian or ICAO and that. And you need to watch for it because in some situations it could be the difference between a right answer and a wrong answer. The best place to go to find out about all the weather that NAV Canada gives us is this chart in the AIM. So in the Met section 3.2 is this table that lists all the weather information and charts and stuff that we are provided by NAV Canada. So for example, the GFA, we know now that it's issued 30 minutes before the beginning of the coverage period. We know that it comes in a package of 3 different times, and they're only these times. They're valid below 24,000 feet, and of course it gives you a picture of the weather forecast. Use these charts to study from because there's lots of information on here that they could ask you about. The 30 minutes before they're valid is a perfect example. The fact that they're valid below 24,000 feet is also good. This is a good summary of the type of things they can ask you because they could ask you, what is this chart for? When is it valid? When was it issued? That kind of thing. So TAFs are here, amended TAFs. The whole table covers everything. This is an interesting one. Did you guys know that all the upper winds in Canada that go above 18,000 feet are issued by Washington, not by Canada, even for Canadian airports? I don't know why, but it is. And then there's a bunch of charts here that you may never have used before. There's some of these that you would traditionally only use for larger airplanes. So there's a lot of charts that you might know nothing about. This is a good source of information on them. And we're going to look at all these things in the Met Practical section. There's also a lot here that you don't need to read. Everybody knows what a METAR is. Everybody knows what a PIREP is. So some are more handy than others. Now this is a big one here, the upper level analytical chart. These charts, this will be the last one we look at, they are published for particular pressure levels. So the chart you get would be, for example, a 250 millibar chart or a 500 millibar chart. And one of the questions they could ask you is, approximately what altitude is this chart valid for? And the only place to find that answer is here. So 250 millibars is approximately 34,000 feet. 500 millibars is approximately 18,000 feet. So that's on this chart. It's the only place to find it. So know that for the exam, those 4. I've looked on the NAV Canada website for these recently, and it looks like they've stopped issuing the 851. I don't know why. It's still in the AIM. They still have a tab for it on the NAV Canada website, but when you click on it, there's nothing there. So I'm not sure what's going on right now. We talked about this in HF radios, I believe. What's a BALMET?
Weather broadcast.
Yeah, it's a weather broadcast on HF. Apparently they're also on VHF, but they're only really ever used on HF. And it gives you access to what sounds like an ATIS, well beyond ATIS range. So if you're still 3-4 hours away from an airport and you want to find out what the weather's doing, you can tune to this VolMet and it'll broadcast it the same time every hour. Now today with ACARS and all that stuff, nobody ever does it, but it's still there. All right, let's look at METARs. This should be pretty easy. I know we all know how to read METARs. A couple of things that people tend to forget. Remember, the direction of wind is always in true, not magnetic. Visibility is always prevailing visibility, which means the guy who's measuring the visibility looks at an arc at least 45 degrees wide, and whatever the visibility is in that direction, that is the prevailing visibility. Because it could be different in different directions. They look at the majority, the prevailing. Vertical visibility is in hundreds of feet, of course. It's illustrated like this, VV 100. Temperature dew point spread, I'm pretty sure we all know that one. Altimeter setting. Wind shear in a METAR is written like this. So they'll put WS for wind shear, followed by the runway encountering the wind shear, runway 34. Here's another METAR. This one has a correction in it. Whenever corrections are made to METARs, they'll do CCA for the first correction, B, C, D, etc., etc. RVR, runway visual range, will be written in a METAR by individual runway. You'll never get an RVR for the whole airport. It's not how RVRs work. They have to be for a particular runway. So this one here is runway 11 as RVR 700. And then they follow with a letter to represent whether that RVR value is improving, getting worse, or pretty much stationary. So this case here, it's N for no trend. So it's sort of sitting at 700 and not moving. The descriptors. We know most of them, but there's always those few that everybody screws up. And I'm going to point them out because I screw them up too. In the remarks section, they will refer to the types of clouds or obscuring phenomenon, and then the number afterwards tells you how many octaves of coverage it has. In this case, we have fog, and it's covering 8 octaves. And then mean sea level pressure here, 1013.0. Remember, how do we calculate mean sea level pressure, and how do we calculate altimeter setting? Does everybody remember? So we take your station pressure and we apply a correction. What are the two corrections? So altimeter uses 15 degrees at sea level and the standard lapse rate of 1.98 degrees per thousand feet. Mean sea level pressure uses 1.98 degrees per thousand feet, but what temperature does it use?
8-hour average.
Isn't it the
temperature over
average?
past 12 hours?
Yeah, average over the last 12 hours. Good.
12 hours.
So that's why they're both stated here, because they both should be different values unless the average temperature for the last 12 hours was 15 degrees. It's the only time they would be the same. Good. All right, here are the descriptors. This table's in the AIM. You can find tables like this everywhere. It's pretty much ICAO standard. The ones that everybody seems to get tripped up on, snow grains versus snow pellets. That's one that people get tripped up on, don't forget. Some people forget shallow and patchy, even partial sometimes, so watch for those. IC for ice crystals, PL for ice pellets, GR for hail, UP for unknown precipitation. The ones that won't be on the exam, don't worry about dust storms and sandstorms, dust, sand. That's not going to be on the exam. We don't really encounter that anywhere here in Canada, or dust and sand whirls. Mist versus fog. A lot don't realize, but the only difference between mist and fog is the visibility. So if it's more than 5/8 of a mile, or 5/8 of a mile or more, I should say, they call it mist. If it's less than 5/8 of a mile, they call it fog. That's the only difference. All right, so just watch for those. The most common one is snow grains versus snow pellets, just because they both have an S and a G. All right, this is also something that people get tripped up on. the octus, the coverage of cloud layers. In a METAR, it's important to realize that cloud coverage is based on a summation of the layers. That means when they report a cloud layer, they include the layer below it when they give you the coverage. So if you have multiple layers of clouds, you do not have a very accurate indication of how much cloud coverage there actually is. And I'll give you some examples. So if this is what you were looking at, 3/8 cloud at 2,000, 2/8 cloud at 6,000, and 3/8 cloud at 7,000, it might not actually be 3/8, 2/8, and 3/8 on the screen. So let's look at here. There's 3 layers. Layer 1, 3 octaves. So how much is that? Scattered, few, overcast, what is that?
Scattered.
Scattered.
Scattered. So we got 1, 2, 3 octaves of the sky is covered. Now that is scattered. The second layer is also covering 3 octaves, which should be scattered. But the problem is because it's a summation, the system doesn't recognize what may be hiding behind layer 1. So what it's going to do is it's say, okay, I can see 1, I can see 2, but I can't see what's behind layer 1, so I'm going to assume that there's coverage here. So it'll be reported as if 5 octaves of the sky is covered. And what's that then? It's not scattered anymore.
Yeah, be broken 6.
Broken.
Exactly. So despite the fact that it's actually a scattered layer, because it's based on a summation, the system that looks up at the clouds is going to assume that there might be clouds hiding behind the lower layer. So now it's reported as a broken layer. So let's look at layer 3. So we can see 1, 2, 3. So the machine could report it as scattered, but it doesn't know what's hiding behind the lower layer. So it's going to count 4, 5, 6, 7, 8 octaves, because they're all obscured by the lower layers. Now in this case it's correct, but it very well could have been another scattered layer. You don't know. It's a summation. So it's important to realize that what's displayed in a METAR may not be the truth. It is assuming the worst. It's a summation. Don't worry, I got a couple more examples for you, but just keep that in mind. METARs are based on a summation. So in this case, it should be scattered, scattered, overcast, but it's reported as scattered, broken, overcast. Here is a vertical viz. So now we got cloud fog coverage. So in this case, we got half statute mile fog, vertical viz 500. A vertical viz is telling you how far the machine is seeing through the fog or the surface-based obscuration. If you have fog, you're not going to see any layers above it. So you won't see if there was scattered or fewer overcast because it's covering 8 octaves. So if you were given this question on the exam, you're flying to this airport at 10,000 feet and you're looking down, how much of the how much of the sky would be covered by cloud? So remember, it's a summation.
At least 5/8.
At least 5/8, exactly. You're looking down and you can see from 10,000 feet, there's a scattered and broken layer reported. So that means you know that by it being at least broken at 2,000, that at least 5/8 of the sky is covered. Some look in the remarks section and say, oh, it is absolutely 5/8 because I got 1/8 of stratofractus, 4/8 stratocumulus, that's 5/8. That's a summation as well. It doesn't know what's hiding behind this first layer. So it could be 4, it could be 5, it could be 6, you don't know. So all you can say for sure that is at least 5/8. Okay, so don't look in the remarks section to answer this question, you'll get it wrong. All right, good, sweet. All right. You're given this METAR for Fredericton. What is the minimum increase in opacity of the surface-based layer in order for it to constitute a ceiling? So what do they mean by the surface-based layer?
Obscurity.
Yeah, which is fog, right? So we have fog. That's the surface-based layer. How many more octaves coverage does there need to be for it to constitute a ceiling?
2 more.
2 more 8s because it's already 3 8s.
Okay,
5/8.
why is it 5/8?
Yeah, because it's 3, it needs 5 more to make it
No,
to
5/8 is broken.
constitute a ceiling. Yeah.
Okay, why does it need 8 octaves to constitute a ceiling?
It could be 5 as well, so maybe 2 is more.
Ground-based ceiling.
It's ground-based. You're absolutely right. So under any other circumstances, a ceiling is considered broken or overcast, right? So broken is 5/8 and overcast is 8/8. So normally a ceiling is anywhere from 5/8 to 8/8 coverage. However, for a surface-based layer, it has to be a full 8 octaves for it to be considered a ceiling. So fog or mist only constitute a ceiling if they cover the full 8 octaves. If this question says, what's the minimum increase in the opacity of the stratus layer, then B would have been correct. But because it's a surface-based layer, the fog, it has to be C.
No, it's like
This is a trick on the exam.
Accidentally.
So remember this one. For a surface-based layer, it has to cover the full 8 octaves.
I accidentally.
When that happens, when this fog becomes 8 octaves coverage, what else will change in this METAR?
It's reported as vertical viz.
Exactly. All of a sudden, it would say fog, half mile, something like that, vertical viz 5 or 4 or whatever it is, and then you won't see anything about that broken or overcast layering because the machine that measures the clouds can't see it. So the moment you have a surface-based layer becoming this ceiling, you get a vertical viz. Good. Know that for the exam. It's an exam question. So this is what was just being shown. We had that surface-based layer covering 3 octaves. Then there's stratus clouds, and then there's another layer. And in this case here, they're actually all pretty much scattered coverage, but that's not how they're depicted in the METAR because it's a summation. First one, fog, would just be in the remarks section, but that layer 2 is being reported as a broken layer, 6/8. Layer 3 is called overcast because it's 8/8. Good. I think I did that to death. We know how summations work now. So let's look at AWOS, so automated weather observations. So most airports that report proper METARs, there's a guy there. There's an actual individual taking the weather measurements. You can see it. Automated stations, it's done by a machine called a ceilometer, I don't know how to pronounce it, ceilometer. And it measures the clouds directly over the sensor. Visibility as well is also measured in whatever direction the sensor's pointed. So it's not really a prevailing visibility like we would get from the tower because the machine is just going to measure what it's pointed at. So keep that in mind when you look at an automated weather observation. Now, sometimes you might also see what's called a limited weather information system. And that is an AWOS, but it's very, very basic. It doesn't give you cloud information. And it doesn't give you visibility information. All it gives you is winds, temperature, dew point, and altimeter. This is on the exam. What is an LWIS? And it still says auto. You'll see it in the statement, but it starts with LWIS instead of AWOS. Still an automated system, but there's no clouds and no visibility reported.
What does the equal sign mean?
Same question.
I can't figure out that calculation.
All right, any questions on METARs? Pretty straightforward. Those are just the tricks to look for on it. Now we'll talk about GFAs. GFAs are issued as a group of 6, and they are to cover the entire forecast period. So when you get a package of GFAs, they'll all be sent out at the exact same time, and you'll get 3 clouds and weather, and you'll get 3 icing and turbulence. First 2 are at the time they're issued, or at least close to it. Then you'll have +6, and then +12 hours. So they're valid at 6-hour spacing. So this one here, you can see the top one is valid at 18 Z, the next one's midnight Z, followed by a 6 Z. And then you get another 6 of them issued close to midnight Z, and they'll be for midnight 6 and 12. When are they issued? How long before the first one do they issue the group of METARs, or sorry, the group of GFAs?
30 minutes.
30 minutes before.
30 minutes before the first ones are valid, right? So 30 minutes before the top one, they're going to issue all 6 of them. Why is that important? Well, in the top right corner of a GFA is the title box. And you might actually just be given the title box, as silly as that sounds. So they'll give you just the top part here. And they'll ask you, is this the first, the second, or the third clouds and weather chart?
It's the first,
So looking at this, is this the first one, the second one, or the third one?
based on the issue time.
Hmm.
The Valentine's the first.
So
It's
you're
the first one.
It's the first one, right? It was issued at 1731 and it's valid at 18 Z. That's about 30 minutes. So this must be the first one. If it was the second one, then it would be 6 hours and 30 minutes later, right? It would be midnight Z. If it was the third one, it would have been at 6 Z in the morning. So based on that issuing time, you can determine which of the 3 charts it is. And that could be an exam question. I don't know why it's important, but it's an exam question. So you just look at the issuing time and compare it to the validity time, and you can determine which chart you're looking at. All right, the legend box doesn't change. It's always the same thing. It's going to give you an idea of the most hazardous weather that could be depicted on a GFA, and they also give you a little scale at the bottom. I hate to tell you, but you might need that scale. The way you use it is you put a piece of paper up to the scale, you trace it over, and you turn that piece of paper into like a little ruler that you can move around on the GFA in order to measure distances. Because you could get questions like, how far is the cold front from Halifax? Or how far away is the severe icing from your flight? That kind of thing. So you might actually need to measure distance on a GFA, which sucks, but that's how you do it. The comments box is below that, and in the comments box, they can put a bunch of stuff. One of the things they'll do is they'll use it to remove some information from the graphical part of the GFA. So this basically removes some of the clutter. So if they can't fit it in here or it's going to get too messy, they'll just put it in the comment section. And then you just use the letters for the corresponding area. That's what the comment section's for. There's also this note on all the GFAs. Heights in ASL unless otherwise noted. CBs, TCUs, and ACCs imply significant turbulence and icing. CB implies low level wind shear. This is important. Now, this is written on a lot of charts, not just GFAs. You can see it on 4 or 5 other ones. What's important about it is if you're asked a question on the exam to talk about icing and turbulence you might encounter on a flight, the icing and turbulence charts don't tell you about ACCs, TCUs, and CBs. They're just going to tell you about icing and turbulence. So if you're given, for example, a question where it says, okay, you're doing a flight from Saskatoon to Calgary at 18,000 feet, describe the icing and turbulence you might encounter en route. Most people go to the icing and turbulence GFAs. They'll look at what's going on between Saskatoon and Calgary, and they'll write it down, and that's their answer. But what they won't look at is the clouds and weathers chart to see if there was any TCUs, ACCs, or CBs that you can encounter on that route. And they imply a whole bunch of turbulence and icing on their own. So make sure if you're given a question to describe icing and turbulence that you look at these charts as well to see if there's any of these convective clouds that could change your answer. So watch for it. Force yourself to look at all the information. Everybody's gonna say, okay, I'm talking about icing and turbulence. I look at the icing and turbulence chart, but that's not the whole story. So watch for it. All right, the third of the 3 clouds and weather chart includes something called an IFR outlook at the very bottom. And the IFR outlook is a very, very generalized statement about IFR conditions. Now, what's considered IFR is less than 1,000-foot ceilings and or less than 3 miles of visibility. So in this statement here, it's very simple, and it's just talking about those regions where you could encounter IFR flood. So for example, here it says rain, snow, mist over southern Quebec, rain, mist over southern Ontario. You would never want to go flying based on a weather report like that, but they still include it on this chart. Now, what's also important to know is this IFR outlook box makes this GFA last longer. It's not valid for 6 hours like the other charts. This one is valid for 12 hours. It says valid from 6 until 18Z, not 6 until 12Z. So the fact that this little tiny box of nothing information makes this chart valid a lot longer. So if I asked you on the exam, how long is the validity of a package of GFAs? So all 6 of them, how long are they valid for? What would you say?
Six plus 6, 24 plus another 6.
30.
So the first one's valid for 6. The second one is valid for 6, so that's 12. What's the third one valid for?
12. That's right.
12.
Okay,
So that's 24.
24. Okay.
Okay. What people forget is the outlook box. A lot of people would say it's valid for 18. They'll say, okay, 6 plus 6 plus 6 is 18. But it's not 6. It's 6 plus 6 plus 12. It's a full 24-hour validity with a package of GFAs. And it's all because of that little IFR outlook box.
Stupid question, would it be like 24 and a half?
No. Why would it be 24 and a half?
It's valid for a half hour before it's reported.
No, it was issued a half hour before. It's not valid till the first time.
See.
So they issue the charts, but they don't become valid till the time on the chart.
Didn't you say in the beginning that there are 6 sets of charts? Or
There are 3 clouds and weather, and there are 3 icing and turbulence.
oh, all right, 3 of each.
Yeah, so the charts have the same validity. They're just mirrors of each other.
So it means the outlook section will only be in the 3rd chart.
It's only in the 3rd clouds and weather chart, only in this one. There isn't one on the icing and turbulence, but it still makes the package of GFAs valid for 24 hours.
He's still doing this.
All right.
How long is
Make sense?
Good for
Yeah, but in the icing, you just put the cross.
There is no IFR outlook here.
All right. Oh, yeah.
Yeah, so this chart is technically only valid for 6 hours, but this one here is valid for 12. It's all semantics. Does it really matter? Not really, but
Yeah, for the
it's an
exam.
exam, right? They ask you what they want to. Because to be quite honest, if you were using these for your flight, you would probably have grabbed a new set of GFAs before you're anywhere near that 24-hour period.
Correct.
So it's just meaningless questioning. All right, let's look at the actual graphic part of the chart. So I'm sure a lot of us are comfortable with GFAs. It's really not rocket science, but just to remind you what some of the symbols mean, there's usually arrows and numbers representing the speeds of the pressure systems and the fronts. They're only depicted if the speed is greater than 5 knots. If it's less than that, they would put the letters QS there, which represents quasi-stationary, which means it's stationary but not. Organized groups of clouds will have that scalloped border around it. And remember, clouds on a GFA are only below 24,000 feet because that's all a GFA is valid for. The only exception is any convective clouds, like CBs, TCUs. Then they might give you the height of the cloud, even if it's above 24. For example, here it says isolated CBs up to 270. The reason they do that is because the height of a CB is representative of the severity of the storm. So by giving you a cloud height, you can kind of understand, well, how bad of a CB are we talking? Not that there's a good one, but you know what I mean. If it's not broken or overcast, they won't put the scallop border around the clouds. So they'll just have the words somewhere, you won't see a scallop border. If those scattered or few clouds are mixed with overcast or broken, they will include it in the scallop border. But on their own, scattered and few would not have that. What also is important to know is that cloud coverage on a GFA is not a summation. So what you see on a GFA is what you can actually expect. Scattered is scattered, broken is broken, etc., etc. Okay, so they are not summations. Surface-based layers are shown as obscurations. So obscured ceilings 3 to 500, obscured ceilings 2 to 300. The 2 to 300 or 3 to 500 that they're talking about is actually a vertical visibility. It's not the height. It's the vertical visibility of the obscured layer. Visibilities are pretty straightforward. Precipitation will be written as either continuous or showery. So if it's showery, they use a dotted border with the hash marks. For continuous, it's a solid border with stippling inside. So there's dots in there. I know it's hard to see on Zoom, but there's dots inside there. Areas of obstruction to vision are surrounded by this amber dotted line. And they are only used if whatever that is not due to precipitation. So fog and stuff like that would be there, but if it was heavy rain and visibility was half a mile, they wouldn't put an amber dotted border in there. It's obviously half a mile due to all the other weather. Those would be standalone obstructions to vision.
It says orange, man.
Orange, amber. Same
Okay,
thing.
orange.
Yeah.
Okay.
Is that orange?
Oh,
Yeah, I guess that is more orangey than amber. You're right.
Yeah.
Okay. Spatial coverages. Here's where it gets silly. GFAs are created and issued by Canada. So if you're looking at a GFA, what you're looking at is something that's done in Canadian format, which means all the spatial coverages, the words isolated, occasional, patchy, all that stuff have a percentage coverage. And you need to know what they are. Because you'll read a GFA and maybe they'll say there are isolated thunderstorms. Isolated CVs topping at 350. And when you're choosing an answer, it's going to say there are CVs covering less than 25% of the area with tops at 35,000 people. So you'll read the word isolated, but the answer is going to give you percentage. So be able to do that. Here's the stupid part. These percent spatial coverages are different than the ICAO standard. Canada uses different spatial coverages than ICAO. So if you looked at an ICAO chart and saw the words isolated, occasional, frequent, all this, the numbers are different. So this only applies to a Canadian chart. So watch for it. Because it's a Canadian chart, this counts. I will point out the other ones for you and I'll tell you what the ICAO ones are. But
Is it the high level one?
sorry?
Is it the high level one?
Oh, there's a bunch of them. Don't worry.
Oh.
Yeah. So just remember these are Canadian. So write these down, put a little note at the top, only applies to Canadian charts. Now, I'm not gonna lie, it's not that bad because the ICAO values are just 25% more. So if you look at an ICAO chart, it's not less than 25, it would be less than 50. If it was 25 to 50, it becomes 50 to 75, and then frequent wouldn't be 50, it would be 75 or greater. So it's not like it's that different, but it's different and you need to know it. I don't know why Canada just can't make it ICAO standard. I don't see what the big deal is, but they absolutely will not do it right now. Isobars, remember these? don't forget, this is a good opportunity for them to ask you to identify what a particular isobar value is. And you can see it still follows what I told you. 1,000 is the baseline, everything's 4 apart. And they connect, of course, areas of equal pressure, and air flows parallel to the isobars. They are on the clouds and weather charts. Wind is depicted using the traditional wind barb system. So remember, all the flags are 10 knots, half flags are 5 knots. If you have a pennant, it's 50 knots. And they point in the direction the air is going. If it's gusting, they'll put a box, the letter G, and then the gust intensity. So if you saw this, what is the direction and speed of the wind?
20 from the
Northwest, gusting 30.
225 kilometers.
20 gust to 30.
Blowing.
Wait,
So it's
20
from the
is your
northwest
airplane's
at
nose.
20 gusting 30. Good. Piece of cake.
Where the tail.
Think of the barbs as the wings.
All right, the icing and turbulence one. So the other 3 GFAs will look like
And the
this.
point is the nose.
The way
of
it's
the
formatted on the right is pretty much the same. You're still going to have a title box. You'll have the validity and issuing times. The legend, of course, is a little bit different because this is giving you icing and turbulence. So instead of giving you freezing rain and thunderstorms, it gives you different symbols. It still has the same note about CVUs and all that stuff to remind you. And then it still has a comment section and all that. Inside the graphical area, there's much less to know. It's going to just give you icing and turbulence. So for icing, they have blue. That represents either moderate or severe, and they will tell you the type of icing, whether it's rime, clear, or mixed. And you'll see that the stippling and the density of everything increases for severe, so it's more blue, less blue if it's moderate. The one thing that isn't here is light icing. Light icing will only be put in the comment section. They will not depict it graphically on the chart. So on these, that's what the comment section was used for. Same thing for turbulence. Light turbulence is in the comments box. Moderate and severe turbulence is put on the graphical part of the chart. Same thing with turbulence though. They'll label exactly what's causing the turbulence: mechanical, low-level wind shear, mountain wave, low-level jet, clear air turbulence. And the red represents moderate or severe. More dense hash marks, a darker red line for severe versus moderate. And believe it or not, the direction of the hash marks means something. If it goes one way, it's representing low level, and then if it goes the other way, it represents high level turbulence. So it allows them to kind of give you an illustration of layers of turbulence if they have to. And then density would be like this. They don't give you isobars on the icing and turbulence, they give you freezing level in hundreds of feet ASL. So if you're given icing conditions, it could say moderate clear turbulence from the freezing level up to 10,000. So if you need to figure out where the freezing level is, you would look for these dotted lines. And they're all spaced 2,500 feet apart. If a GFA, regardless of whether it's clouds and weather or icing and turbulence, has a correction, they do a similar thing to METARs. They'll put a CCA or a CCB or a CCC or something like that. So that's how they would illustrate corrections. Now, once a correction has been issued, that means they have to update the issuing time. You can no longer tell whether this is the first, second, or third GFA anymore, because it just doesn't make sense. Could have been issued after it was valid in this case. So you don't know. Here are the common symbols they ask about on the exam. They could give you a symbol that you might find on a GFA. You should know what these ones are. So obviously the bottom 4 are easy. Just watch out for these other 3 or 4. Now there's a bunch. These are the ones that are on the exam. And then, of course, know the other symbols that could appear on a GFA, fronts, stationary fronts, things like that. Know them in both black and white and color, just in case, because you might get a black and white image instead of the full color GFA. Depends on your exam. And your exam center, actually. Some exam centers just print them in black and white. All this stuff, it's in the AIM. And it's in every MET textbook you can find. So corrections to a GFA are done if there was a mistake. So CCA, CCB, if they illustrated something incorrectly or they made a mistake in drawing something, they will issue a correction. But if something happens that wasn't forecasted, they will issue what's called an amendment. So it's not that a mistake was made, it's that something's occurring that's not expected. What do they do to amend a GFA? What can they issue? Anybody know? What amends it?
Maybe a SIGMAT?
Airman.
Yep, SIGMETs, and another one, AirMets. Both of these things can amend a GFA. Now, what determines whether it's a SIGMET or they issue an AirMet is the severity of the weather
SIGMAT's
that's
worse
occurring.
than AirMet.
Severe weather will issue a SIGMET. Less severe is an AirMet. So SIGMETs are considered significant meteorological weather warnings. And they're issued by the Weather Office and provided to pilots transiting our airspace. The two centers in Canada that issue SIGMETs are either going to be Montreal for the eastern half of Canada, or they'll come from Edmonton, which covers the western half of Canada. Now, the intent of a SIGMET isn't just to amend a GFA. That's not really the whole purpose of it. It's not there for amendment purposes. It's there to draw your attention to the fact that some sort of significant meteorological condition is occurring. Something like thunderstorms, tropical storms, heavy hail, wind shears, all this stuff could drive the creation of a SIGMET. Now, usually if this was a known condition, it would be included in the GFA. But if it's not something that was forecasted, they'll issue a SIGMET. Because SIGMETs could be important for any pilot flying through Canada. Even if you're not flying to a destination in Canada and you're just flying through our airspace, these SIGMETs could be important. Every country will issue their own SIGMETs. They cover their own airspace. So SIGMETs for Canada are issued by us, for any pilot. They are valid for, until they're updated or canceled, first of all, but usually they are valid for 4 hours. When Canada issues our SIGMETs, they issue them twice. They issue them once as an international SIGMET and once as a national SIGMET. Again, this is some extra complication Canada has created for themselves. So you need to know one that's in our national formatting, and you'll need to know one that's in ICAO formatting. So we issue them twice, every time. One goes out to all the pilots, that's the ICAO one, and the rest of them are available to Canada, which is our national one. Like I said, they're valid for 4 hours. Otherwise, they need to be either corrected or canceled. The only exception to the 4-hour one is if it's tropical storms or volcanic ash reports. They can be valid for much longer. So what's the difference between the international and the ICAO? So these are two identical SIGMETs. One's in ICAO formatting, one's in national format. And they're both talking about a squall line. So if you read them both, you can actually see that the description of what the weather is identical. So we got Winnipeg Flight Information Region, squall line, thunderstorms and hail observed within 25 miles of a line from here to here to here, topping at 400, moving eastward at 25 knots. The national one, same thing. Winnipeg Flight Information Region, squall line, thunderstorms, hail within a line of blah, blah, blah. And it's still topped at 40,000, moving eastwards at 25 knots. What are the differences? Who can see them?
The list of the airport.
So the national one is referencing airports, 25 miles southwest of CYQK, CYRL, 60 northwest of CYPL. The ICAO formatting has to be just latitudes and longitudes. You're not allowed to reference airports. So that's the one big difference. What's the other difference?
The nationals are marking which GFA it's referring to.
Bingo. The national formatting tells you what GFA this is amending. The ICAO one doesn't mention anything. Those are the two differences. So how you read it is the same. There's just those two. The other thing that does differ is like those words isolated, frequent, occasional. The spatial coverages are also different. But it's not so common to see those in SIGMETs, so you won't run into it on the exam. You will run into this other thing though. The position references and the remark about which chart it's amending. So again, why do we do it twice? I don't know, maybe it's a make work project. Now, SIGMETs will also amend another chart that we're going to look at soon called significant weather charts. AirMets, on the other hand, only amend GFAs. AirMets are different in that they're usually referring to less hazardous weather conditions. We're not talking about thunderstorms and tropical storms anymore. All these are really mentioning are things like icing or turbulence that may be encountered in areas that weren't forecast. So when we have an AirMet, the only thing they are going to amend is the GFA. They do not amend that other chart, significant weather chart, that we'll get to in a minute. So some guy at a Barron encounters some turbulence. He makes a pilot report to ATC. That could create an AirMet. And the AirMet, again, comes in two different forms, the national and the ICAO. So the national one here is at the top, same thing. It references airports. It references the GFA that it's amending, whereas the ICAO one only uses latitude and longitude, and it doesn't mention any other weather chart. So if you read one, you can read them both. Any questions on that? You guys want to do TAFs and then take a lunch? Does that sound good? All right. TAFs. So this is in the AIM. This shows you a map of Canada and all the airports that issue area forecasts. Depending on which airport it is, they could have 12-hour TAFs, 24-hour TAFs, and two of the airports actually have 30-hour TAFs, Vancouver and Toronto, which are the busiest. So that depends on which airport you go to, you're going to get different lengths of TAFs. And not only that, but a TAF can only be issued from an airport that has a manned weather reporting station. So if the airport closes or works limited hours, the TAF is also limited by those hours. The reason is if they're going to issue a TAF, there has to be somebody there to make sure that the forecast is coming true. Otherwise, that would require they change the TAF. So you're never going to have an automated TAF. It doesn't work that way. The TAF is created by somebody. TAFs are valid 5 miles around the center of an aerodrome. Where are METARs valid?
10 miles.
5 miles on the reference point, the center of the runway or aerodrome.
Nope. That's where a TAF is valid. METAR is different. It's not 5 miles.
10 miles?
Nope.
Isn't it just the aerodrome?
Yep. Just at the airport. Good. So TAFs are valid 5 miles around the center of an aerodrome. METARs are only valid at the aerodrome. So within the fence, basically. Good. Things to watch for on TAFs. Of course, the validity times are here. So this tells you when this TAF is valid. 16th day on the 18th hour to the 17th day of the 18 hours. So this is a 24-hour TAF. Again, winds are always in true. We know visibility and how to read it. The next forecast is due by, in this case, midnight Z. It's at the end of the statement. they like to ask questions about these validity times and all this stuff. I don't know why they focus so much on it, but they do. So this one here is for Toronto Airport, and it has a 30-hour forecast, 18 until 24 the next day. And at these airports that have the longer TAFs, they actually end up updating them far more often. This time, this one's coming out within the next 3 hours, there's gonna be another 30-hour TAF. So not only are they longer coverage periods, but they're also updated more frequently. Less busy airports get updated less often. So this one here is a 12-hour TAF. Sometimes you can note whether an airport is closing by looking at the validity time of the TAF. So like I said, it's either gonna be 12, 24, or 30 hours, unless the airport closes. So in this case here, you can see this TAF is only valid for 8 hours. So by looking at that, you can tell that this airport must be closing at 4Z, right? Because it's not 12, 24, or 30, it's less than that. So now you know when the tower closes. So if you saw this TAF given to you on the exam, and they said, how long will the next TAF be valid for? What would you say? How long would the next TAF be valid for?
8 hours?
2 hours.
2 hours. The next TAF is coming out, it says in the remarks section, by 2 o'clock. And if we know by looking at the validity time that it's an only 8-hour TAF, that means it's closing at 4. The next TAF is going to go from 2Z until 4Z. Be a pretty short TAF. Meaningless information, but an exam question. So TAFs are valid 5 miles around the geographical center of the airport. They can be amended or issued late. Wind shear on a TAF is put a little bit differently than it is on a METAR. Here, this is telling you wind shear 01127.055. What does that mean?
1100 and the wind.
The runway?
Nope.
It's at a height of 1100 AGL, winds are from 270 true at 55.
Bingo. There's no runway on this one. So what it's telling you here is winds are 190 at 18 gusting 28, but at 1100 feet, the winds are 270 at 55. That's the shear. It's going from winds of 190 to winds of 011. Or sorry, 270. What the hell am I saying? So it's shearing, looks like 80 degrees. And all that occurs at 1100 feet. Good. The word vicinity. So if TAFs are valid for 5 miles around the center of an aerodrome, the word vicinity means 5 to 10. METARs are only valid at the aerodrome, so a vicinity on a METAR means within 5 miles. Know those for the exam. So vicinity means something different in a TAF than it does on a METAR. I know this isn't an INRAP exam, but unfortunately you are going to need to know how to determine suitable alternates. So you need to know your alternate weather minimum. The easiest way to do that when you're using your ETA is to break all the TAFs down by the froms. And then you'll know which region of the TAF you should be working with. Because every time the word from is used, they have to restate all the weather elements, even if none of them change. So you never have to worry that you may have missed something before the from, because they have to restate regardless. So once you know which area of the TAF you're working with, it makes it a little bit easier. All you're going to be looking for is whether the weather is below alternate minimums. Now you need to look at also things like becomings, probs, tempos, and stuff like that. So just as a refresher for you, becoming represents permanent changes that are occurring in a period of time. And only 2 things can be included in a becoming. Otherwise they use a from. So the maximum things that can change is 2. Now, the weather could be improving or getting worse over that becoming. So if the weather is getting better, assume that it doesn't happen until the end for the purposes of alternate selection. If it's getting worse, you assume it happened at the beginning of the period. So this is all worst case scenario, right? And then whatever the weather is, it can't be below published alternate minimums. With tempos, this means that there's some sort of fluctuation occurring temporarily over the period of time. Now, tempos, there's some rules about it. Each fluctuation cannot be longer than an hour, and the number of fluctuations in that period can't be more than half of the period. So if it's saying, for example, here it's saying tempos between 2 and 10, that's an 8-hour period. So the fluctuations can't last longer than an hour, and there can't be more than 4 hours worth of these fluctuations. That's what it means. Tempo conditions can't be below your published alternate minimum, of course. Prob 30 and Prob 40 are the percent chances of hazardous weather occurring. So it's not going to be Prob 30 of clear skies. It would be Prob 30 of something like thunderstorms or hail or whatever. With the probs, it's a little bit different. When you use alternate selections, it's not below your alternate minimums, it's below the landing minimums. This is the one that's different for alternate selection, if you forgot. Now, there's a table inside the CapGen that's worth knowing for the exam. That's how we select our suitable alternate, right? It's based on how many usable approaches there are, whether they're precision or non-precision. Just remember, in Canada, APV or LPV approaches, whatever you want to call them, are not considered precision approaches. The only precision approaches in Canada right now are ILS, MLS, and PAR approaches. The GLS ones are still not approved. So it says it right here, no credit may be taken for LPV or LP lines of minute. So if you're asked on the exam if you can do it, you cannot. Okay, so this is the table that you'll probably want to review before going through the exam. I'm sure if you've done flight planning on your own a few times, you've got it memorized. So just be prepared to know what the minimums would be based on usable approaches. And remember how that sliding scale works for the 602 or the 802. It's the sliding scale. Good. I know it's not fair. You have to rate your INRAT. Why would they ask you again on the ATPL? There could be a question where you have to do it. Could be. All right. You guys want to take lunch? Let's take lunch. So everybody back at 10 minutes after 1, and then we'll get into upper winds.
Good.
All right. Everybody have a great lunch. I will see you in 45 minutes.
Thanks, friends.
Take care.